Welcome to lecture series on action. Today we will see about one more collision resolution technique, which is linear probing. So in the previous lecture, we have seen what is the separate chaining, which is the simplest collision resolution technique. Today we will see about linear probing. In linear probing, collisions are resolved by sequential scanning of array until an empty cell is found. So if you want to insert the items, let us see an example. If you want to insert the items with keys 89, 18, 49, 58, 9 into an empty hash table, and table size given as 10. So the hash function that we generally use is a key value modulo table size, right? Now see, for each key value, we got the hash value as 9. For 89 it is 9, 18 it is 8, 49 it is 9, 58, 8, 9 it is again 9. So by default, if you want to insert 89, it is inserted into index 9, and 18 is inserted into 8. Again, if you want to insert 49, what will happen is, it will be inserted in the index 0. How it is, so first it will check the hash value. It is 9, right, for 49. But in 9, we already have a key value. So now the key value is incremented by 1. So 49 plus 1 would be 50. So 50 modulo table size would be 0. So this value 49 is inserted into the index 0. Now again, if you want to insert 8, you will increment it by key value. 58 should be inserted in index 8, which is not possible. So you will increment the key value by 1, 59. So the key value would, hash value would be 9. Again, it is not possible. You will increment key value by 2. It will be, has to be inserted in 0th index. Again, it's not possible. Now, if you increment key value by 3, 51, sorry, 61, but modulo 10 would be 1. So 58 is inserted into index 1. Similarly, 9 plus 1, 9 already we have a value in the index 9. So plus 1. In the 0th index also we have value. In the first index also we have value. So 9 plus 3 would be 12. 12 modulo 10 is 2. So 9 is mapped to the index 2. This is how linear probing will work. So what all I have explained, I have said so far is explained here. Here a standard insertion we have seen. If you want to perform deletion, standard deletion is not possible. So as long as the table is big enough, a free cell can always be found, but the time to do so can quite be large. Even if the table is relatively empty, blocks of occupied cells start forming. This effect is known as primary clustering. Any key that hashes into the cluster will require several attempts to resolve the collision, and then it will add to the cluster. So average number of cells that are examined in insertion using linear probing is roughly 1 plus 1 slash 1 minus lambda whole square divided by 2 for a half. A full table will be obtained 2.5 as the average number of cells examined during an insertion. So primary clustering is a problem at high load factors. For half empty tables, the effect is not a disastrous. An unsuccessful search costs the same as insertion. Cost of successful search of key is equal to cost of inserting the key at time X was inserted, at the time the key was inserted. For lambda equal to 0.5, average cost of insertion is 2.5. Average cost of finding the newly inserted item will be 2.5, no matter how many insertion follows. Thus, the average cost of a successful search is an average of insertion cost over all small load factors. Average number of cells that are examined in an unsuccessful search using linear probing is roughly 1 plus 1 slash 1 minus lambda the whole square by 2. So these are some of the examples for the analysis we have done for successful and unsuccessful search. So hope you understood linear probing. Previously, we have seen a separate chaining, which is the commonly used collision resolution technique, which inserts value as in the form of linked list. And in case of linear probing, each time collision occurs, key value is incremented by 1, and value will be key will be inserted into the next empty slot or the index. So this linear probing, it comes under open addressing. The collision resolution technique is broadly classified into two. One is separate chaining and other one is open addressing. So under open addressing, we have linear probing, quadratic probing, and unknown technique. So in the next video, we will see about what is quadratic probing and how it helps in resolving the collision. Hope you understood this video lecture. So thanks for watching. We will meet in another video lecture.